Right, on the shark bite, which numbers do we want to see? Do go over
4.
1, 4. That looks like the majority. 1 and 4. So we'll do those two. And then you're going to turn in your answer sheet today, and this will be the last shark bite that we do for the rest of the year. Alright, for number 1, translate the expression 4 times the difference. So we are multiplying this by this. And then difference we are subtracting. So 4, then in parentheses, a number, pick whatever you want, minus 2.
Can you put the 4 on the other side?
You can, but usually it goes in front to show that you're distributing. You usually don't distribute backwards, but you could as long as you put parentheses. Other questions on that one? Four. Simplify. So this one you just had to combine like terms, especially since you're adding. You don't have to change any signs. So we only have 1 x to the third, so that's going to stay out front. Always highest exponent to the lowest. Combine your x squareds. -2 minus 4 would be -6. Exponents don't change since you're just simplifying. We only have 1 x, and we only have 1 y. So 5x to the third minus 6x squared plus x minus x. Make sure your names are on your shark bite answer sheet and pass those up. See the email that I posted. So we're taking our unit 10 and 11 tests on Thursday. That is also the deadline to finish your other 2 tests from last week, because otherwise they'll be graded as is. Remember, I'm still dropping the lowest 5. So if some of you already started asking about retakes, you can still do retakes, but also remember I'm dropping the lowest 5, so you may not need to do those retakes, so hold off on that. Next Thursday is the last day I'm accepting late work, missing tests, retake work, all of those. Okay, sorry. Questions about those first? Yes.
For Thursday, we can finish the test up after school, right?
Yes. For those, for the previous one, Thursday is the last day to do the previous tests, yes. If you do need to finish those tests, you may not have time in class today or Thursday, so definitely come see me today, tomorrow, Thursday after school, or in the morning to get them done as soon as possible. I gave almost all of you exemption form. Make sure you get both parts signed. Bring the whole thing back to me, and I'll cut off the bottom part so that you are exempt from the final, which is the 13th. Okay. Questions about any of that? Okay. So just like last week, we're going to go through the review. Whatever questions you guys want to see, do go over, and then go on to the next one. Okay. So let's start with this first one, the mixed factoring. This is all 10.1, the factoring. Different forms of factoring. It won't be sectioned by like GCF, difference of squares, grouping, all of those. They'll just be mixed in, and you'll have to know what type of factoring you'll need to do. Here are some guides that might help you. Always check for GCF because all of the problems could have it. If it's 2 terms, it's either going to be GCF or difference of squares or both. If it's a trinomial, you're going to be using this as slip and slide, but I changed it on yours. Either the rules for the basic trinomial or the rules for the a is greater than 1. If you see 4 terms, you're doing grouping. Okay, so on the first page, which of those do we want to see? Can you go over and disregard the ones I've already sent you? You can also choose those, Regina.
Can I say like a few again?
Sure.
1, 3, 6, 7.
1, 3, 6, 7. Jaden, did you have one? Okay, let's start with those. If you have others, we'll go to those. So first, look and see, does this have a GCF? Is there something we can divide out of both that they have in common? What? 7b. So remember that you're placing whatever that is outside of parentheses. You don't have to show this part, but I'm going to do it just so we remember what happens. We're dividing each piece by 7b and seeing what would be left. So 4a squared minus 9. Right? And then we have to double check that we cannot factor this anymore. So it has two terms. Does it have any more GCFs? No. Two terms is also difference of squares. Are these perfect squares? Something times something equal 4 and something times something equal 9? Yes, so they are.
So like, if you just did it by b, then
it would be half. You would have to keep going, yes. So this is your difference of squares in here. So keep bringing down your DCF. You're going to have two factors. Difference of squares, you're looking for what times what will give you 4, and it has to be the same number. 2. What times what will give you a squared? Times a. What times what will give you 9? I'm ignoring the negative. 3. And then put a plus and 1 and a minus in the end. So you may have some just GCFs and that's it. You may have some difference of squares and that's it. You may have a mixture of both. Just depends on the problem. Questions on this one? Two, does that have something you can divide out of each thing? Yes, what? 3. So we're going to divide everything by 3. What would be left?
3 in parentheses m squared plus 3m minus 10.
So now we have a trinomial inside. And it doesn't have anything in front, so this is a basic. So we're looking at two numbers that multiply to be negative 10 that also add to be 3. Add or subtract to be 3. Switch that and then yes. Negative 2 and positive, and yeah, positive 5 would work. Let me redo this.
So is this replacing our m?
No.
We wrote an a. Oh, that's a
We said positive 5, negative 2. Keep bringing down your DCF, and you're going to have two factors. Whatever the variable is, put that first in both. And then the two numbers, put those in those. So plus 5 minus 2. Do you have any questions on that one?
And it doesn't matter what order it's in.
No, you can put 3 and then m minus 2, m plus 5. Same thing with this one. Does not matter which one comes first, the plus or the minus. Right, number 3. This has 4 terms. Even so, still look and see does it have a GCF for all of them, because sometimes that happens. Is there something we could divide out of each of these? No. So then has 4 terms, so we're doing grouping. Split it down the middle. And look for the GCF of just the first 2. what would that be? X squared. And then we're dividing that from these first two. What would be left? X plus 2y. Then we do the same thing for the next two. Look for the GCF of these two numbers. What would that be? 4. But whatever this sign is, you bring that down. So negative 4. And if we divide out negative 4, the signs are going to change. What would that be? With grouping, your insides should look the same. If they're not, something's off. So then you rewrite it, whatever's on the outside. Put in a set of parentheses. And then whatever's the same, just bring down one of those. We didn't do this for the last one or after we found this answer. But here we could not divide anything else. We couldn't use GCF or difference of squares. Same thing here. Can we factor either of these more? Which one? So we're going to have 3 sets of factors. This one is going to just be the same. What would these two factors be?
X minus 4 and X plus 4.
Not 4. Christina, what were you going to say? 2. Plus 2 and minus 2. Okay, so always make sure that you can factor more, because you'll lose points if you don't factor it completely. Questions on that one?
Is this how our test is going to look, or did it just come by?
Alright, number 6. Look for GCF first. What is something we could divide out of each piece? If we're dividing 3xy out of everything, what would be left?
Minus 2y plus 1.
Now the difference between this one and number 2 is that this is a trinomial, yes, but this isn't squared. So I cannot use the trinomial rules on this. Is there anything else I could divide out? So then that is the final answer. That is it. Questions on that one? Number 7. Is there something we can divide out of each? Or what about variables? How many x's? There we go. Divide that out of each one. What's that?
Minus X.
Here we do have a trinomial. It doesn't have any other GCFs. We have something in front of x, so this is not your basic. This is your a is greater than 1. So here we're multiplying 2 and negative 6. And we're looking for two numbers that multiply to be negative 12, but add or subtract to be negative 1. So think about your factors of 12, and then you're going to have to make one of them negative.
Negative 1.
Yes. But this is different than what we did before, because we have to rewrite this into 4 terms. So keep bringing down your GCF. The first and the last stay the same. The middle you change to the two numbers you just found, but with the same variable. So 2x squared minus 4x plus 3x minus 6. Now we have 4 terms, so we're going to use grouping. Split this down the middle. Keep bringing down this GCF. What do these first two have in common? 2x. If we divided that out of both of these, what would be left? Yes. And then same thing. 3 is the GCF of the last two, so plus 3, leaving x minus 2. I'm going to rewrite this on here. So then we still have this GCF from the beginning, 4x squared. Then the things on the outside, 2x plus 3, we put together in one set of parentheses. And these are the same, so we just bring one of those down. So at this point, we've covered all the different types of factoring, GCF, difference of squares, just GCF. We haven't done just a difference of squares, but we have done that multiple times. Basic trinomial, trinomial where a equals 1, a is greater than 1, grouping. Are there any other questions on this page that we want to see do go over review? What about the back of this page? Some more factoring problems, and then we'll jump to the next one. Let's start with those. So 14 is 4 terms. So which type of factoring are we going to use? Grouping. It doesn't have a GCF. There's nothing we can divide out of everything. So split it down the middle. What do those first two have in common? 9x squared. If we divide that out, what's left? Plus y. And then you can do the next part if you want. No? Okay. What do the next two have in common? Jaden? -1. So if you don't see anything they have in common, it's always 1, but this one is negative because it has minus. And what would be left? Plus y. So then we have two factors, 9x squared minus 1 and x plus y. Can we do anything with either of those? Yes, what? What could we do with it? Your difference of squares, yes. So 3x minus 1, 3x plus 1, bring down the x plus 1. Questions on that? Let's jump down to 24. Does this have a GCF, something you can divide out of everything? 4y. Yeah, I was going to say 2 works, but it's not the highest, so 4y. But remember, you could do whichever number as long as at the end, if you see that you could factor more, keep factoring. So 4y, what would be left? Emma? So we have 3 terms. We don't have any more GCF. Yes. There's nothing in front of the x squared, so this is your basic trinomial. So So you're looking for two numbers that multiply to be 9, and then those same two numbers that add or subtract to be -6. Sometimes the numbers are the same. -3, -3. So then what would these factors look like? The variable that you have and the numbers you just found. X -3. And then the same thing. Or you can write it as 4y times x minus 3 squared. Either or. What would you do? I saw it on my computer and then I looked back and I was like, oh. Right? Any other factoring questions?
Would you take either one of those numbers?
Yeah. Right. 19. What do we do first?
Finish one question.
Okay. Do we have one?
Yep.
5xy. Divide that out of both. What's left?
X squared.
Can we do anything else? Yes. What?
I don't know what it's called, but I don't know.
What were you gonna say?
X minus 1.
So your difference of squares, or those. Now can we do anything else? No, it's done. Other last factoring questions? Yes. Does it have a GCF? No. So there are only two things that you can do for two terms. So what's the other one? Yes. What would that be? Not dividing by 2, but what times what will give you 100?
Oh.
10.
10 minus 3.
And then there's nothing else we can do after that. Alright, go on to the next page. So the next 2 pages, front and back, are for your last objective in 10. I was going to say factoring again. Dividing your polynomials. But some of those are also dividing polynomials by monomials. So on this page, find any you want to see. Do go over.
1 and 3. Oh, and 3.
Let's do those and then we'll go forward. So number 1, here, this is really just remembering your exponent rules. Actually divide the numbers, and we're dividing the basis, so we're subtracting. That part won't be on the test. It'll be more like 4 and on.
So cut it.
Yeah. Oh, okay. 3 is the same, so 1 and 3 wouldn't be something you see on the test. It'll be more like 4 and on. But divide 20 and 24, it's going to be a fraction. What would that fraction be?
24?
And then subtract all of your exponents. You have a to the -1. You wouldn't have any b's. And c to the third. So c would go where 5 is, and a would go where 6 is. is helpful that you remember those for everything else. For 8, these are the problems that you could do one of two ways. Either take each piece and divide it separately, so like 10b squared divided by 5, 5b divided by 5, and minus 15 divided by 5, and see what you get afterwards. So what would this be if we did it like this?
2 plus
And we're not factoring, so that would be it. Or you could look at what is the GCF of the numerator. What do those have in common? 5. Divide it out of just the numerator. So you have 2b squared plus b minus 3. So it's still all over 5. But then these 5's cancel, leaving just this. So you get the same answer either way. Questions on 8 before we do 9? So you don't have to do both methods, you just have to know one. So for 9, do we want to split it or find the GCF? Okay. So what would the GCF of the numerator be? Invariants. What would be left when we divide that? And then the 3 C's would cancel, just leaving that. So you could either rewrite it without the parentheses or just leave it either one. Circle it, something that I know this is the final answer. 12. You want to split it or find the GCF? Okay. So split it into two things, negative 20x squared over 5x. And negative 5x over 5x. The last one's going to be negative 1. And then what would this one be? Because you're subtracting that exponents. Other questions on this page? Split it or GCF? Okay. Sometimes you may try it one way and the other way might be easier because some of them will give you things where you have like different fractions, I guess. Divide that, what would you have left?
To the power 6, e to the power 2, and c minus 1.
Any others? Say that all one more time.
The way that I do my work is I repeat it.
You have to separate it.
Okay.
I am going to show you one that didn't work well. So like 7, 18, and 19 all don't work well. Because when you go to divide it, let's say for 7, we were doing it separately. This one works out fine because it's 4x, but this one, because there are higher exponents in the denominator, you're going to end up with a negative, so you're going to end up with a fraction. So be mindful on those if you separate it. Some of them will have that, but I tried to put on the test which of those are. Other of these questions? Regina, do you have a question? No. Alright, look on the back of this. Any of those questions? Regina. QCF or split?
I don't know.
You just choose.
Split.
Oh. Okay, so divide those and tell me what you get. Oh, I wrote wrong. You were. Any others on this page before we do the last part of the same objective? Split or DCF? So 21, then we're doing DCF, and then we'll go to the next page. So what is the DCF of your numerator? So whatever that first one is, if it's negative, you also have to take out a negative. So let's divide that out. What's left? Now, when you do GCF, if these are exactly the same, they can cancel. If they're not the same, you'll have to divide them, simplify it, and then multiply it back in. So that gets a little confusing. So if this was like negative 5x to the third y squared, you would have to take these two and simplify it, and then distribute it back. Go on to the next page. So these are the last parts of Objective 10. This is more of what you'll see, but then you'll also see some of what we just did, dividing polynomials by binomials, where you have to factor out the numerator and then cancel like terms. Okay. Which of these do we want to see you go over? Jasmine? Any others on this first page? Let's start with one. So this is a basic trinomial. There's only a 1 in front. So you're looking for two numbers that multiply to be 21 and add or subtract to be negative 10. What two numbers were? write those as your two factors, x minus 7 and x minus 3, but don't forget that this was already divided by x minus 7. And cancel out your like. Questions on that one before we do the next one? So what's nice about this is that you'll have all your factoring methods that you just did on factoring, and you can go back and flip back and forth, like, how do I do this, just in case you forget. Right, for this one, there's something in front of x. Does this have a GCF? No. So then multiply 2 and negative 12. And we're looking for two numbers that multiply to be negative 24 and add to be 5. What two numbers would work? Because this is your trinomial that is a is greater than 1, you're going to have to rewrite this into 4 terms. So 2x squared minus 3x plus 8x minus 12. Every time you do a new step, keep rewriting it as a division problem. That way you don't forget that we were actually dividing and not just factoring. Split this down the middle. What do these first two have in common? X, which would leave us with what do these last two have in common? Plus 4, yes, which would leave us with you could probably see which one is going to be the like term that you cancel, but rewrite it with your final factors first. And then questions on that or other questions on this page? Emmett. It wasn't. I'll fix that. That was me just looking at it fast. So the opposite is the answer. Other questions on this page? Or the next page? The division problems look different, but they are still the same. Stop. Let's do 16 because 12 is very much like 12 is actually different. Okay. Caleb, what were you going to say? 15 is like, what number is that? What does that say? Yeah, so that one's like this one, so it'll be the same. Alright, do 12 and then 16 and then we'll switch gears and go on to the other one. So here, if you want to rewrite it into a vertical, so it helps you, you can do that first or later, does not matter. Does this have a GCF? So if we divided that by 2, what would be left? is which type of trinomial? Basic or a is greater than 1? Basic. So look for two numbers that multiply to be negative 35 and add or subtract to be negative 2. Negative 7 plus 5. So keep bringing down that 2 from the outside, and then we have d minus 7 and d plus 5. So the d plus 5 cancels, and you have 2 times d minus 7, or you could distribute it. Either answer would be fine. Questions on that one? Yeah.
So, that is basic.
You don't multiply. Correct. You do not do that. You can, but that would be more work. You don't have to. 16. We have 4 terms. What type of factoring are we using? Grouping. Split it down the middle. What's the DCF of the first 2? X squared, which would leave us with? What's the DCF of the last 2? Positive 8, leaving us with? Should be the same. Okay. Rewrite into your final factors x squared plus 8 and x minus 3. And our final answer is we're not going to do a bunch of problems from the second one, but we will still do it. So go on to the next. The calculator you have. So for the quadratic regression, yes.
Okay.
Of these, we can either do one of these or one of the graphing. Actually, we'll do one of these and one of the graphing because we have to do the graphing. Okay, so your axis of symmetry is x equals negative b over 2a. Where the numbers in front of these are a, b, and c. So to find our axis of symmetry, x equals negative 10 over 2 times negative 1. And what would that give us? Yes. To find your vertex, you have to show this part, and then how you do it is that you put 5 in for all of your x's. So show that you put the value in for x. Then you can either do that on your calculator, all together, separately. You could type this in to your calculator. So I'll show you what I'm looking at. What was the last one? go to your table, and we said the axis of symmetry x value was 5, and look at the y value. So any of those methods you could do, but then you need to write this as an order pair. 5, 3, 3, and 3. Questions on how to find the axis of symmetry or vertex? We're going to do one of these. Okay, so same thing, find your axis of symmetry for this one. So we have a negative 8 over 2 times your a value here is 1. What would your axis of symmetry be? And 4. So x equals 4 is your axis of symmetry. Put 4 in for all of your x values. And either do that in your calculator or type this into your y equals. Look on your table, find when x is 4, find the y value. What do we get? So vertex would be 4, negative 1. Then the graphing aspect, put the vertex in the middle. Sometimes it'll be outlined like this, sometimes it won't, but put it directly in the middle. Fill out your x's, go backwards and forwards. So backwards, 3, 2, 1. Forwards, 5, 6, 7. Put this into your calculator. Was it plus 8 or minus 8? And then what was the last number? 15 plus 14. 15, 15. Go into your table, second graph. Yeah, I thought I pressed that one. And then go into your table, second graph. Find the number in the middle, and then fill out the rest of your values. So 0, 3, 8. Once you have half of them, the other half just repeat with a mirror. Graph all of those points. Some of the graphs you'll only be able to do 5 points. 5 is really all you need. More is just extra. And then what is the domain of this? For this left or for this right? Where does it start? Where does it end? These are arrows at the end. So either your XER or negative infinity. Either or. What about the range? Where does it start? Where does it end? Sorry.
-1 and then it goes on.
So in set builder notation, that would be everything greater than or equal to -1. In interval notation, it would start at 1, -1, with a bracket and go to infinity.
Yeah. Can you do like, so like the domain, could you do all the numbers and then the other one can be -1?
Sure. You don't have to do the same thing for both. You just have to do one or the other. And then the zeros, where does this cross the x-axis? 3, 0, 5, 0. We see that in the table, but we would write that as a solution set, 3, 5. If it says write it as an ordered pair, then you can write it like that, but otherwise, write it as the solution set. Let's do 8, so we can have an example where you are solving this. Regina? These 3s. Right, so if you get a problem like 8, you'll need to get everything on the same side. I'm going to subtract x squared and 2x so that everything is on the same side. Is this 2? This number? Okay. And then, after you have everything on the same side, you're just factoring again. So, a lot of factoring. This is which type of trinomial? Your basic or your a is greater than 1? Basic. There's nothing in front of x squared. So we're looking for two numbers that multiply to be -72 and add to be 1. Add or subtract to be 1. What numbers work? If you're not sure, start dividing 72 by 1 by 2, Regina.
Wait, not doing my calculation. Oh, -9.
Oh.
-8 and 9.
-8 positive 9.
Oh, you're getting positive 1. Yeah, I thought it was
The other way. So you have your factors, set them equal to 0. Then you set each one equal to 0. And solve. Now, when they're just like x minus 8, x plus 9, you don't actually have to do the work to solve, you can. But if it's like 2x plus 3 or something like that, actually show that work. Because these are always going to be the opposite. And you would write that as a solution set. So again, you can actually show the work, add 8 to both sides, subtract 9 to both sides, but you don't have to do that part if it's just a x plus 8, x minus 9 example. Do we have any questions on that? I will have the steps for the calculator and Desmos on the board. But we're going to review how to do this in the calculator. And then I'm going to find any others that may be different that we haven't covered. And then be done. So here we know we're using curve of best fit, or the quadratic regression because we have to think about how this went. It was discharged vertically in the air, eventually has to come back down. So we'll make that U shape. So in the calculator, put this into it, go into stat, go into edit. If there's anything in your L1, L2, go up to the top, hit clear, and come down. And then put the seconds in L1 and the height in L2. You can either hit the number and enter or the number and the arrow. Once you have all of the points in, go back into stat, scroll over to calculate, and now instead of number 4, it's number 5 because we're in quadratic regression. If you do number 4, you'll get the wrong things. I'm going to store this one because it's asking for specific things. Alpha trace at store regression, and then hit enter 3 times. Write the equation down even if that's not what it asked for. So y equals or f of x equals either or negative 16 x squared plus 200 x plus we need the height after 10 seconds. So we're going to make our x value 10 by typing in 10 from that screen, the STO button, x, enter. And then to actually get our answer, alpha trace and enter twice. So the height would be 403 feet. Regina? If we have time. Other questions on that? Fine. This page. And when you get to this page, number 4 on the bottom and 5 and 6 on the next page are very similar, but this would be in the second objective along with the solving. So the Algebra 1 Unit 8 test at the top, but number 4 at the bottom. Right? For this, if you have factors and it gives you something like this, it can't be linear. So it has to be one of these two. When you are looking for the answers, you either have to set these equal to 0 and solve them so you know exactly where they would cross the x-axis. Where would these cross the x-axis? find which of these two match. That crosses at -2 and positive 4. So notice that this has -4 and 2, that if you don't remember to solve it, it's going to give you that answer. We've basically covered all of the stuff that's going to be on the quadratics test. So the first section is your axis of symmetry, graphing, vertex stuff, domain and range, all those. Second objective is solving by factoring. Either you have the graphs and you figure out the zeros or something similar. Or it'll be something like solve by factoring, you factor it, and then set the things equal to 0. And then the last section is the quadratic regression. So really quickly, I'll do that same problem in Desmos, and then we'll be done. So I know you guys are starting to pack up, but also listen. So in Desmos, you would add in your table, put in all your values. You can zoom out to see those points. And then put in your line curve of best fit. You can put in the y equals, you don't need it. If you do need ax squared ax1 squared, because these have ones. So ax1 squared plus bx1 plus c. You need the y equals, my love. Not the equals, just a little out of my brain. There we go. I was like, that's not it. And I didn't put y on my.
It's okay. We did a lot.
Yes, we did so much. There we go. Now it's finished. It would give you the numbers. You write that as an equation, and then the x equals 10. You just put that and find where it intersects. But I'll have those steps for you, just like last time. Right after we do the Padlet and attendance, you guys will have the entire time to take your tests. I'll have the instructions on this board, and then anything else I need to tell you, I'll tell you next class. If you need more practice, please come see me today, after school in the morning, or after school tomorrow, or Thursday morning. And then come finish your test if you need to do that. Now you can back up, put your calculators up. We are also going to draw names on Thursday.
That's number 19. I have number 19.